Welcome back to the Fullerton College Print 101 class. This is Professor Ben Kiewit, and this is part 2 of my offset lithography lecture. Now we're going to talk about plate mounting. In the previous video, scroll up, plate material, we talked about printing plates and how they're made and what they're made out of. Now we're going to talk about how they get attached to the press. There are different methods of attaching the plate to the plate cylinder. The straight kind has no alterations done. It's simply a rectangle of metal, and there are special clamps that will hold on to the plate itself, just gripping onto the edge through sheer clamping pressure. Then there's something called pin bar. A lot of the presses at school use this. Pin bar is a bar with lots of little tiny nails on it. And those little tiny nails go through little tiny holes on the edge that you have to punch on the edge of your plate. And the edge of your plate kind of looks like spiral notebook paper when you punched it. And those little pins can be kind of sharp, and they bite sometimes when you put them on if you're not careful. So that's pin bar. It's a way of holding it in place that's not just mechanical clamping pressure. It also has physically putting things through the holes to hold it in place like a binder. Lastly, serrated is a combination of a pin bar and a bumpy cut edge to make sure that it's aligned exactly straight. It's very important that your plates are aligned perfectly straight because the alignment of the plate on the cylinder determines how straight you're going to be printing to that paper that you're feeding through the press. So the plate mounting matters. You can actually sabotage your printing efforts through a poor mounting of your plate. So modern plates now are mostly done through a photo direct or laser system. Previously, in my father's time in printing, in commercial printing anyways, before he went digital and more into development. Anyways, sorry. In the earlier times, we would use a film method of plate development. The plates themselves may not have changed that much. They're still light sensitive, they have emulsions, and they're either positive or negative acting. One of them will automatically like water until you remove part of it. Other ones will automatically reject water until you remove parts of it. Photo direct and laser means instead of making film like they used to do, instead the lasers, you have a laser system that will actually expose the plate pinpoint by pinpoint with a small laser beam in the correct wavelength of light. Otherwise, you use film like in the old days where you actually make large film negatives and you expose them on a exposure tables, very similar to how you make a screen printing screen through the film, and the light goes through it. That involved large cameras and lots of film developing. That's not very commonly used anymore. So here's a very close-up cross-section of a printing plate. You can see that at the very bottom, that gray thing's the metal plate. And on top of that, you have different bits of material, different layers. And each one of those layers does something. The top layer is just there to be removed. Below that, you have layers that are sensitized to the light, and that can either harden or not harden depending on if it has light done to it. Below that, you have a hydrophile layer, which is a layer that likes water. That's the part that will get wet when you add the dampening solution. Below that, you have an oxidation layer, an electrolytic sand layer, and aluminum on the bottom. All those layers are important, and you remove the parts of the top layers that you don't want. Again, I can't tell you definitively which part you remove because there's two types of plates. Positive acting and negative acting is kind of hard to understand. So let me tell it to you this way. If it's a positive acting plate, that means that if you don't do anything to the plate, if you take it straight out of the box, don't develop it, don't expose it, you put it on the press, positive acting will print the whole page dark, solid colored with whatever color ink. I was going to call it black, but that's only if you put black ink in it. That will print the whole page. Negative acting means if you don't do anything to the plate and take it out of the box and you put it straight on the press without exposing or developing it, well then it's not going to print anything at all because it will only absorb water. So positive acting likes ink until you remove the parts you don't want. Negative acting likes water until you remove the parts that you do want to print. That's the difference. I may have gotten ahead of myself there a little bit. So computer to plate plates, as opposed to just film exposure plates, these are the ones which are exposed by laser on a plate developer, or a plate exposure, or a plate maker, a computer to plate CTP system. There's lots of names for it. These are the ones we use on campus. You make your design on the computer, you send it to an output system that goes through a raster image processor, a RIP, and the RIP converts all the information you created on your computer into dot information. It's still made out of dots. They're just very, very, very tiny dots. A decent plate maker will make your plates at 2,400 dots per inch. That's a decent plate maker. A really good one will do in the 9,000 range, and crummier ones will do less. Digital printing is limited to about 1,200 dots per inch for the maximum resolution it can handle. But anyways, 2,400 is pretty good. And the dots are so small, you probably won't even notice them. And these dots aren't even the halftone dots you normally print with. No, these are the dots that you can use to make the halftone dots that lets you vary the size of the dots you're going to print, which lets you vary the amounts of ink you print. So computer to plate, good stuff. Now, a soft image, this is a soft image. A soft image has fuzzy edges and it's not very well defined, and it kind of seems to fade away at the sides. This is a problem you can have if you're using traditional film-based plate exposure. This happens when you don't get a very good seal and light somehow gets through the edges of your film negative and unfortunately creeps out and causes, again, it's just called image softness, causes the image not to have the crisp edges it should have had. Also, bonus points if anyone can name the airplane here in the foreground of the picture. This is the only plane, this is one of the few times I've been up in a plane that's smaller than a passenger plane, and I do actually have stick time on this to brag a little. It's a fun plane. If you name it, be warned, I might talk airplanes with you sometime. Anyways, moving on from this beautiful Boeing that's printed improperly. So we're back to talking about the offset press systems. So again, the offset press system, each unit in an offset press prints one color of ink. A full-on printing press or press system will have multiple, often, although it's possible to have just one. In the old days, 1 and 2 were common and popular for small presses. Now it's mostly going to be 4 units up because people want full color imagery. So these 4 units, each one prints one of the colors, one of the primaries of cyan, magenta, yellow, and black of printing full color printed images. Each one of these has its own ink system, its own dampening system, its own plate cylinder, its own blanket, and its own impression. Because you need all of those to print any one color of ink. So each unit, each color requires all that equipment to print that one color. Feeding systems. There's 2 types of feeding systems. There's web presses and there are sheet fed presses. The web press prints from a web, and a web is a giant roll of paper. It's hard for me not to think toilet paper when I see it, and that's really rude because toilet paper is only one kind of paper. And it's kind of stereotyping to say that. There are so many types of paper available. Web presses print on a giant roll. Sheet fed picks up already cut out sheets. Like if you buy paper at Target or Walmart and it comes in a little ream of paper and you pull out individual already made sheets, a sheet fed press would print that. A web press would not. A web press requires a roll. So we're going to talk sheet fed for a minute. To feed sheets, there has to be equipment to pick it up and move it in. There are 2 things in this picture, 2 pictures here. On the left, we have a sheet separator that blows little puffs of air between the paper so that the sheets of paper don't stick next to each other. Next, you have a sucker foot. By the way, if I ever start a band, I'm going to call it Sucker Foot. It's a great name for a band. Sucker feet, little suction cups that actually suck air through negative pressure to lift up the pages and put them in. So the separator blows a little puff of air, and the sucker foot sucks a little bit to pick up the paper and to put it into the press, 1 sheet at a time. There's also double sheet detectors. The presses are set up, built, calibrated, and maintained to allow 1 sheet of paper through at a time. If you print 2 at a time, not only do you have a blank sheet that didn't get printed between there, but it also throws off the balance of everything. The exact impression, the distance between the cylinders that allows that paper controls the amount of pressure that's being put on them. And if you run multiples through, you can cause it to jam, you can cause it to throw out of calibration, you can cause all sorts of problems. So a double sheet detector is there to make sure that only 1 sheet goes through at a time. Double sheet detectors can be as simple as a small electronic finger that makes sure that only one goes through. You can have like a gap set so only 1 sheet can fit. Through more advanced electric ones, this is a piezo ceramic system that actually has an electric pulse that can see how much resistance the paper is giving to an electric pulse to a sensor and tell it if there's more than one. On digital presses, you often have something called a retarder roller, which is a wheel spinning the wrong direction underneath to make sure the bottom sheets don't go through just the top sheets. Here's a press cylinder. This is a plate cylinder. The plate wraps around the cylinder. This one uses a weird magnetic system to attach the plate. I've never used anything this fancy or advanced. Mostly I just use pin bar systems. But you can see that around it wraps the plate, and that's the important part of this. Let's talk blanket cylinders now. So the blanket cylinder is what makes an offset press offset. In fact, some places will even call it the offset cylinder because it's what keeps the paper from touching the image. So the blanket cylinder requires a certain amount of pressure. A certain amount of pressure also means a certain amount of depth of how far does the press cylinder or the plate cylinder push into the blanket and flatten it out while it's transferring the image over. In order to get the right amount of distance, you have to make sure there's packing behind the blankets. The blankets have to have sheets of something behind them to make sure they're the correct depth, and that the depth and the distance they are from the plate cylinder or how far they squish together affects how much pressure is going on, affects how the image transfers. There's two ways of measuring that. You can either do the math. Everybody likes pi. In fact, I'm recording this on Pi Day, March 14th. If you do the math, you can actually compare the distance. If you measure the outer diameter of the blanket and measure the inner diameter of the cylinder, you can figure out how much packing is necessary to make sure that it's going to be the right depth. Also, you can use something called a cylinder packing gauge, which is a tool that measures it like a caliper and will tell you the answer. I am a believer in using machines to do our math for us when possible, just because it's nice to have to make something easier and be able to spend your brain on more fun things. Let's talk dampening. Unless you're using a waterless, no guffawing, stop laughing. I know I said waterless. Unless you're using a waterless press, your press has a dampening system on it. And that's going to be how it gets the water or the fountain solution onto the plate cylinder to make sure the ink doesn't go where it's not welcome. A conventional system uses something called a Detector roller. In this picture, it's number D, and it kind of has a dotted outline behind it. That's because it goes back and forth. The Detector roller, instead of just continually, instead of just continually taking liquid from the fountain and applying it to the plate, a Detector will sometimes get water and sometimes not. It goes back and forth. It touches and it goes away, and it touches and it goes away, like an intermittent windshield wiper. This kind of goes and stops, goes and stops. Depending on how frequent and how long it spends on the rollers that go to the cylinder is how much water it gives. So it's a way of metering the water quantity through the frequency of the Detector moving back and forth. Fountain solution is full of water, gum arabic, and acid. Mostly water. It needs to be a pH neutral, non-mineral water. So distilled water or water run through a reverse osmosis filtration system will work. Fountain solution also comes in a concentrate. Like if any of you grew up, in the 80s and you went to any big family, school, public, or religious events, and they have like punch in the big igloo coolers. You guys remember that red punch that came from like Smart and Final? Ooh, good stuff. That stuff was sweet red nectar. Anyways, that stuff was made with concentrate. You buy a big jug, but the jug contained enough to make 3 or 4 coolers full of punch. So you'd pour some in and add water, and you dilute it to make your drink. Same thing here. You add water to it. Actually, the other way around. You add it to water, because when you're mixing chemicals, you always add the acid or the chemical to the water, not the other way around. That way, if you splash, you're splashing water, not concentrated acid. And also gum arabic. I looked this up. I don't think I put that. I'm sorry, it's not in this one. Whoops. I'll have to put that graph up for you somewhere. The pH, the acidity of fountain solution, in case you're worried about touching it if you ever need to, although you don't want to get a lot of chemicals on you, it's not like acid that's going to burn your skin off or melt your clothes or, burn a hole in the floor. Maybe in its concentrated form, but once you have the fountain solution made, it's actually somewhere between coffee and root beer as to how acidic it actually is in practice. Ink systems. Ink systems take ink from an ink reservoir, also called the ink pan or ink tray, and it rolls it through a series of rollers. There's an ink roller and smaller rollers that will all work it out. When ink comes out of the jar, it's really thick and firm, like if you put peanut butter in your fridge. And just like if you have peanut butter in your fridge and it gets all hard from being cold, what do you have to do? you put energy into it to warm it up. In terms of peanut butter, that means you're stirring it with a knife to make it soft again so you can spread it. The rollers push the ink between them and roll them around and around and around and around and around, pressing and pressing and pressing, and that energy goes into it, makes the ink warmer and thins the ink out so it's a sticky paste as opposed to a solid brick. And after it gets it all good and worked out and made into a nice thin paste, then it applies it to the plate cylinder. So you go through a series of rollers until it's thin enough, and this has already been worked out by the manufacturers of how much is necessary to make it happen, and it will go on to the dampened plate cylinder. It's also possible, I don't have a picture of it right here, that you can have a combined ink water system. What? Combined ink water? I know. Weird, right? But it works because water and ink don't mix, right? Water and oil don't like each other. So if you put the ink on the roller first and then you add the water later in the sequence, the same roller can have a layer of water on the outside and a layer of ink on the inside. And when it prints it against the plate, or sorry, when it pushes it against the plate cylinder, the water dampens first, and then the ink, once the water's been absorbed onto the plate, the ink is free to go onto the plate afterwards. It's a really incredible, fascinating system. I'm quite delighted that they thought of that. Delivery systems is what happens to your paper afterwards. In some senses, you'll end up with a pile of sheet-fed paper piled up onto a delivery pile. Little grippers will, the gripper that grabbed the paper to take it through the press will take it out and drop it off onto a stack, and the stack will lower, lower, lower. If you're talking web fed, it can either be cut into sheets and stacked, or the web fed can simply go onto another web and be spooled up on another giant roll for transport on the other side. Anyways, thank you so much for listening. I hope this was enjoyable. Check out some of the other videos in the feed here, and we'll talk again later.